All right, good evening, wherever you're joining us from. This is Dr. Oladapo Ifeoluwa, and this is the solution to the week 4 session of our ongoing data analysis training bootcamp using SPSS. You remember that from the day one of the training, we had focused majorly on being able to use real case studies because we know that we have a lot of participants across all different walks of life. Hence, the reason we have actually been using different case studies in most of our works. So we have started from week 1, week 2, week 3, and week 4. This is the solution. This one will not take much of our time at all because it's just straight to the point analysis. So it's not going to be a serious challenge if you just need this as a walkthrough for you to be able to analyze your data. So now for case one, we are talking about public health, and the concept here is a chi-square case, and we are asked to check. Question is there an association between outreach intensity, that outreach intensity is categorical in nature. That is, we have none, we have standard, then we have intensive. And the second variable, which is also categorical, that's vaccine uptake. Either they take vaccine or not. That's yes or no. So what do are we expected to do? Now we will even make it easy by giving you how to go about it. Run cross tabs in SPSS, test for the significance with chi-square, stratify result by sex, and write your result. So this is just straightforward. So we come to our SPSS here, then I'll come to my data set. So because in this concept, what we are dealing with is public health chi-square, so I just drag it in. Some of these things we have actually explained in our previous trainings. So we have it now, and we expected to have two variables majorly from the data that we imported. Excuse me. Okay, so we have about we have the heart rate, we have the gender, we have the age, then we have the vaccine uptake. So in this case, we may need to go back to the task. What we expect to do is there an association between the outreach intensity and vaccine uptake. So that's our focus for the purpose of this work. So what do? We come to analyze. I told you to always check your data set before you go ahead with the analysis. So you need the outreach, then you also need the vaccine uptake. So let's just check what we have majorly. So in this case, there is no missing value. We have treated and missing values, and we have different cases for that. You may see our previous videos for that solution. So since our data is up to date, so we can just come straight analyze. I told you come to descriptive, and you will see cross tabs. So you pick your outreach, then you pick your vaccine uptake. That's our focus here. Then you can come to exact, okay, that one is not needed. You come to statistics, we are dealing with chi-square. It's okay. Now, I'm not really bothered with these cells actually, so I won't pay attention. I will ask you to display cluster bar for me, and with that, I should be able to generate my data. I want to try to take away irrelevant information. Yes, so remember I told us in our last class, let's learn to remove irrelevant information so that our work can go straight to the point. So now in this case, this is the chi-square value, and if you look at this p-value, since it is less than 0.05, so we can actually conclude that there is a strong association between the outreach and the vaccine uptake. That's just a summary. So let's come back to the question and just answer it. You say, is there an association? Yes, there is an association between outreach intensity and vaccine uptake. So we've done that. Now they ask us to stratify results by sex. When you hear the word stratify, what comes to your mind is as good as just as separating them. So from what I already taught us, so one can just come straight and data you can just come straight either by splitting into files or you just sort either way. But what we are more concerned with is what I would have done here. I would have just come also, so because we want to just know this intake now. Okay, sorry, we want to stratify it a bit. So we can just decide to, because it's just breaking them into set by gender. So you can just come to data and just split. And if you are splitting now, you now split it by what? You split by gender. Just split by gender and determine where you want to send the output to. Just send where you want to send the output to. That's it for this case. Let's go straight to second case study. That's dealing with ANOVA, education underscore ANOVA. So the student math score differs significantly among A, B, and C. So what this means is we expected. So I'll just control N and just bring in the data set. ANOVA, that's case study 2. Case study 2, education. I really want to go straight to the point so as not to waste much of your time. All right, so we have different things here, but in this context, we have program A and we have the student score. So you see that this gender and school keep coming over and over again, but that's not a concern. Different variables can be part. Our focus is what we pay attention. So the data set. So they said, do students math scores differ significantly among programs? So you know you are dealing with math score and program. So you go straight to this data set, so you come to analyze. I told you to always learn to check the descript the frequency count so as to know whether there's a missing value or not. So we come here. In this context, what do we need? We need program, then we need student score. So with this, we are sure that our data set there's no missing value in the data set. So we come to analyze, we come to compare means, then you take one way ANOVA. Now look at what that is happening here now. So we may not be able to go ahead because the we only have student score here. Program A is not working. So what do? We recode into same variable. So now for me to do that, to make it easier for me, I'd always love to bring my output close by so as not to make mistake with my recode. So I'll be able to see it easily when I'm trying to do recode into same variable. So I'll come to transform, I'll recode into same variable. So program file is what I want to recode. So I'll now say program underscore A, let that one be 1. Then program underscore B, let that one be 2. Then I'll have program underscore C, and that one will be 3. And say okay, then I'll run this. Now I can come to variable view. I'll change this program now. I'll change it to numeric. Then I'll come to value again. So I'll say 1 is program underscore A, 2 is program underscore B, then 3 is program underscore C. So now if I now run this analysis again, you will see that it would have triggered program tab. You see now, so program will come to factor and student score will come here. Then let's check whether we have to do post hoc test. So okay, So we have to run a two-key test. So we want to run the postdoc for two-key test. So come to postdoc, look for two-key here. So we have two keys here. I told you to also learn to add the descriptives. That is majorly for the purpose of your report writing. So okay, so let's check our result and be able to answer it. So since it's less than, then we will say that there is actually a significant difference between the programs. There is a significant difference between the programs. And looking at program A, uh, looking at program A, just come in here, see that even the three of them are significantly different. That is, program A, the score of program A students is totally different from the score of program B and the score of program C. So the three of them, now, this result, this ANOVA is showing that there is an overall difference between the three programs. But we now conducted a post hoc test to know where the difference is occurring, and we found out that is occurring across board. All right, so let's go to case study 3. In order to get to case study 3, I just come here, I control N to get a new page, then I will just find a way of dragging my correlation in there so as to go ahead. So I have my correlation test, not the correlation data rather. I have my correlation data rather. Okay, so I have my correlation data. So let's see what we want to do from the correlation now. Compute PSA correlation between footfall and revenue NG. Create a scatter plot. Then run a partial correlation controlling promo. So we have promo also there now. I remember I told you that partial correlation always involve more than two variables. Promo. So let's get here. This is the data set. See that we now have promo now. So footfall and revenue. That's what we asked to do, Abi. Revenue and footfall. Okay. Very straightforward. Analyze, correlate, bivariate. So we'll just pick footfall and revenue. That's what we want to handle now. So it's PSN correction we are handling. So let's check the result. The result here is not showing significance. That means there is no relationship between the two. There's no relationship between the two at all. The relationship is very weak, but the relationship is not significant. Sorry, let me take that again. This 0.09 shows that the relationship is not significant and is showing a weak positive relationship between footfall and revenue. Looking at analyze, correlate, partial. Now you see that we have the three now. So we have footfall, we have revenue, now controlling with promo. I didn't take this one in the last class. So that's now a partial correlation. So promo, now that is we want to check relationship between these two with respect to promo. With respect to promo. So when we run it, when promo is involved, excuse me. Now if you look at this now with respect, see now that we now have the controls now. So even if you look at it, the relationship is still very, very weak because we have 0.3, though it has, the significance has even gone down. Because look at this one is closer. This one is even significant at 90%. But this is not even significant at any order, even looking at the partial correlation. Partial correlation. So that's just the concept. Now finally, we have for the regression model, and here we handled multiple linear regression model. That is, okay, let me bring in the data first. So FMCG dataset. I must say that there is a difference between linear regression and non-linear regression. So when you have a categorical data, you cannot run a linear regression with it. We have what we call, you can have what we call logistic regression. So a lot of people have categorical data and still end up saying they want to run a regression model. It doesn't fly at all. It does not fly at all. So what is expected is that you should have a logistic regression. In fact, we have what we call exponential regression. That's under nonlinear regression. It's either your regression is linear or it's non-linear. One of these days, we'll create a webinar whereby we'll really dive into really identifying the kind of statistical analysis you are meant to perform on the basis of the data set you have. In my years of consulting for researchers, especially postgraduate researchers, I found out that this is a key problem. A lot of people want to conduct a particular analysis that is not accurate for their data set. And unfortunately, even their supervisors, that's what their supervisor is expecting. So even when you want to tell them that this is not the right thing, it's so difficult for them to admit because their supervisor is not even aware. And most of those people eventually also become academics, and at the end of the day, they are also reproducing students doing the wrong thing because that was what they did during their days. Recently, I assisted someone with their analysis, and that person wanted me to run a regression analysis, bringing a sample from the department that has been approved. And obviously, that sample itself is even wrong. The person had a categorical data, and eventually we found out that you can't be running a linear regression. You will have results, but that result cannot, in any case, cannot be reliable. Obviously, a lot of people also don't pay attention to the case of multicollinearity, the case of autocorrelation, and a lot of assumptions that needed to be checked before you go ahead with running a regression model, especially when it comes to multiple linear regression model. My PhD research work focused on the handling the problem of multicollinearity cases, especially in a nonlinear regression model. What do we mean? When you have, let's say, four independent variables that you are trying to use to predict one variable, and two or more of those variables are highly related, they have a high correlation coefficient, they will surely divert the model wrongly. So any model you generate cannot be reliable because a few numbers of variables have collided. It's just like in parliament, like you have now in Nigerian parliament. If you bring a bill to the government, sorry, to the parliament now, you are most likely going to know your answer before you enter there because all most of them are highly correlated. They are from the same party. They are focusing on the party views over the reality. So that's just the concept of linear regression models too when it comes to the case of multipolarity. But well, for the purpose of this test of this class is for you to at least have a basic understanding of what how to run it. In a subsequent webinars, I'm going to really pay attention at this. And for those of us that may want to join the mentorship class, I would also take my time to explain some of these things deeper and go deeper in a few other things. Look at this now. We are strong multiple linear. So with predictor, so these are the predictor. Price ng. Okay, let me make it easy for myself. Let's find a way to. Okay. All right. So we come to analyze, come to regression, we come to linear. So now, uh, 4. So, which factor best predict weekly sales? So weekly sales of a product is what will be our dependent variable. So sales unit, weekly. This, let me find a way to check weekly. No, this is not week. Shelter coming sales unit. Okay. So this because I want to be sure of our dependent variable really says which of which factor best predict weekly sales of a product. So what are the okay, let's handle the independent force, it will be easier. Price ng, so we'll bring price. Then we have after price, we have ad spend, and that is the advertisement. Then we have the okay, I think I've done that. Then we have the shelf score. Then we have the competitor price. Yes, we have the competitor price. And season. Where is the season? Okay, we have season also. So now, in our own case now, so the only thing that is not there, oh, you see now, you see season is coming as string. So what do? You know the concept now. We can't run this analysis now. So well, firstly, let's see what do we have as season. Analyze, descriptive, frequency. Are you getting the concept now? Let's handle season here now. Because season is part of the analysis. So we only have two seasons. So analyze. So some of us missed this part. Just went ahead. You won't be able to do that. So we recode into save it because it has to be numeric. So you now have value system for what we did. So let's research first. So season comes here. What we did earlier, if you could remember. So we have what we call festive. Festive is one. Then we have what we call regular. Then regular is two. So say okay. Variable. So seasonal becomes numeric. So you can value it. But in this context, I may not bother to even value because it's not really needed because we need the value more. So I'll come back to regression linear. So you see that we have to start over. So sales unit is our dependent variable now. So and I think from here, 2, 3, 4, 5, they all come here. So now if you look at what is expected of us, we are asked to report the R square, the adjusted R square, the F, B coefficient P value, and VIF. Let's check the statistics. Sometimes you also consider the Dobby Watson. All right, so let's just go and check this result that we have here. Oh, okay. It says it's constant. Let me check that frequency. You see, one of the things I spoke earlier. I also did not check this sales unit. And let me put weeks too. Then that week is just oh no. So now in this context now, we can't even use because this is not sales. It's not sales unit that we're supposed to use. I think I messed that part up. It's not meant to be sales unit. It should be this sales unit, so it should be price ng. Okay. So price ng is our dependent variable here. Yes. So is our dependent variable here in this context because this is just number. This is just number. So I think this is the total. This is the price. This is the price. The week spend. Competitor's price. This is our own price. This is competitor's price. Sales unit. This is what I'm supposed to use. Sales unit. You see that there is no sales unit here. So come to analyze again. Sorry. Regression. It will amaze you to know that excuse me, that I've not opened this thing before now. So it's not a pre-done work. So you can be so sure of that. So sales unit. What did we call sales unit here in this context? Sales underscore unit. Sales. Oh, sales unit comes here. Sorry. Yeah, saying now. So okay, we start from season 2, 3, 4, 5. Yeah, perfect now. So we are good to go now. So we have the result now. No, I think I still committed the same mistake. Oh. It's not meant to be says. What's going on here? Let me check the data again. Sales unit, sales unit is okay. Everything here is 5,000. You see the problem? That's the point. Everything here is 5,000. That's why it's actually not running. But let's do it this way in this context. This data, I don't know for those of you that have been able to do it. I don't know how you arrived at your dependent variable because nobody was asking question. Because if you look at this data set now, price NG, there's a price of your own product, season that is on ground. This is the money you spend on ads. This is the shelf score. Then this is the competitor's price. And this is the sales unit. Oh, now I get. Now I understand. So let me check something. Week. Now this is season. This one does not matter. Price. If this is the price, if this is the unit. So we are supposed to multiply the price by the unit to get the yes. Now, please follow me here now. Sales product. So we will create a new variable now. Which of the factor best between weekly sales, weekly sales. So now we'll now say weekly sales. Now we'll come to the transform, sorry, complete variable. So we call it weekly underscore sales. Weekly underscore sales. Now this time I have to determine weekly underscore sales. That will be sales unit multiply. Yeah, am I now making sense? Multiply by price, the price of that stuff. So that gives us something now. So now when we now want to analyze, we now go back to regression, linear. So sales unit comes back, then it comes here. Then we now have weekly sales as the dependent variable. That's what actually gave us tough time anyway. So now you can see that we cannot generate the result now. The R is even 1. What's going on here? How come we are getting account? So something, the problem here actually, to be frank, the problem here is majorly the data. Something is actually wrong with the data in order to identify the dependent variable. But let's use this particular case study, this revenue and football. Let's use it as a regression model since we have identified a concept of relationship. So we come here, regression model, linear. So the dependent now can be let the the revenue we generate, let it not be depending on the footfall and the promo. It's just for context now. Footfall and the promo. So a lot of people have not submitted their assignment. Hence the reason it's so difficult to have identified that there's an issue with the data set in the first place. So look at what we have here as a result. So the R square is even very low. You know, even looking at the model, looking at the result of the correlation itself, it already says there's no relationship between them. Hence, when you even now check, now the R square is trying to check whether the predictor has the capacity to actually help us measure overall of what is being predicted. And the answer is saying no, that this revenue has not a promo cannot explain totally the revenue. Promo and footfall, they cannot. You know, we have even been able to identify that. So no matter the result we have here, we cannot trust it since the R square is completely low. It's completely low. We can no longer trust it. So that best explain the concept of regression model. The issue we have in that sometimes the data set, I told you this one now, look, if you look at, let me even find something out here. So looks like, okay, let me check something if I can. Okay, we used let's come back to analyze linear regression linear. So the two variables that we used will not be part. Let's take them out. We to create think sales unit was part, then amount price ng was part. So let's take out price ng and let's see what we will have. Whether we will have a reasonable result. Now you see that we have a reasonable result because those two variables, because they were part earlier, that was what that affected. You see now they were part of the creation of the dependent variable. So that was why they may not be relevant in the model. They will affect the model because it is the two of them that is creating one. I don't know if we understand this part. I'm going to try to pay attention to this later in the final session tonight to explain this concept very well before we move on to what we have for the last week. Thank you for watching. See you in the live session tonight. Bye bye. All right, before I go, you can always follow me on LinkedIn, on Twitter, everywhere. My name is Dr. Oladapo David Ifeoluwa. Then if you want to follow our social media, just check out for Statistics Graduate Clinic. You will get us. See you soon. Bye-bye.